Friends, have you ever think how machines are controlled automatically and how does it work? And the answer is PID controller. So today we are going to discuss about PID controller. Look friends, if we talk about PID controller is a smart device that controls any process. PID controller continuously checks the actual value, that is process value or process variable, and it compares this process value or process variable with set value or set point, and it calculates how much difference is there, that means how much error is there. And PID controller is used for temperature measurement, for pressure measurement, it is used for flow measurement, level measurement, and any other measurements. For PID controller, some points are very important. They are set point, process value, and error. What are these points? If we talk about set point is the value that we want to achieve. Suppose we want to achieve the temperature at 100 degrees Celsius, then set point or set value will be 100 degrees Celsius. If we talk about process value or known as process variable is the actual value that we are getting. Suppose we are getting 87.5 degrees Celsius, then process value or process variable will be 87.5 degrees Celsius. Now the third one is error. Error is the difference between set point and process variable or process value. Here set point is 100 degrees Celsius and process value is 87.5 degrees Celsius. So the difference will be 12.5 degrees Celsius. So error will be 12.5 degrees Celsius. Set point or set value minus process value, that means process variable, is known as error. Now we will discuss PID controller terms one by one. PID is made from three terms. First one is P, second one is I, and the third one is D. First we will discuss P term. P is known as proportional. Look friends, in proportional term, that means in P term, the controller sees the current error only. It only sees the current error. Suppose the set point is 100 degrees Celsius and the current value or process value is 85 degrees Celsius, then error will be 15 degrees Celsius. The controller sees only this value. Okay. Now, greater the error, stronger will be the output. If this error is increased, then output of PID controller will increase. Then that means the value of P will increase, and if it will decrease, the value of P will be decrease. Fast response but never perfect. It is the drawback of P term. It will be never perfect. The system responds quickly but may overshoot or still have a steady state error. In P only controller, or if we use only P term, then there will be a steady state error or there will be a error. Now we will discuss the second term, that is integral term or known as I term. In integral term, accumulated error is reduced over time. Here error accumulates over time. Okay. In P controller sees only current error, but in integral term, the error accumulates over time. If the error remains over time, the integral term add up the errors. It will add up the errors. Now, integral term control action increases the output to reduce the error. If we use integral term with proportional term, then steady state error may reduce to 0 also. Okay, and we will get process value near about the set point. With P only control, overshoot occurs and steady state error also remains. The integral term eliminates steady state error by continuously increasing the output based on the accumulated error. Okay. The important point about I term is it eliminates steady state error and it brings the system output very close to the set point. Now we will discuss the third term of PID. That means D means derivative term. Here error rate of change is considered. That means derivative term detects the speed of error change. It detects how fast the error is increasing or decreasing. Look friends, if error is increasing very fast, then derivative output will be higher. If it is increasing moderately, then its output will also moderate. And if error is decreasing very fast, then derivative output will also be fast. Derivative term predicts and counteracts fast changes, reducing overshoots and improving stability. Derivative terms are used to reduce the overshoots and to improve the stability. If we talk about the conclusion of PID controller, it continuously checks everything, balances and takes action. Process variables are measured. Temperature, pressure, flow, level, these are the process variables. They are measured. And in PID controller, continuously monitoring, compare and decision are made. Look friends, PID controller output is given to any actuator. This actuator may be valve, heater, pump, etc. This actuator takes action as per the controller output, and then the system or plant is controlled. Then the feedback value of process variable is given to PID controller again. PID controller again compare these values, again give output to any actuator. So this process is a continuous cycle process. So friends, that was our video. Thanks for watching the video. For more instrumentation videos, subscribe to our channel today. Thanks for watching the video.